All right, on to section 2. What are some possible effects of this warming that is occurring for us? Well, first of all, let's have a couple quick definitions for you. There's a distinction that needs to be made, and I use these two terms interchangeably quite a bit, and it's a problem I need to fix a little bit. But global warming and climate change are actually not the same terms. They're different. Global warming, by definition, is the temperature of the troposphere is increasing as a result of the natural greenhouse effect. That's global warming. So this doesn't involve people at all. It's just a naturally occurring thing that happens. Global warming is. Climate change, on the other hand, which is the term that we now hear in the news and stuff all the time, the reason why this is used is because climate change is a bit of a broader term than global warming. It's referring to any changes in the Earth's climate. And so it then can involve man-made issues as well, very easily. And so that's why the distinction's made, and that's why you see a change in the way the terms are used in public so they can be more accurate. So, also important for you to remember when we're talking about these possible effects is that we're not talking about local weather here. So you can't go outside and go, oh, we have global warming when it's snowing. That's not an accurate way to have this conversation. We're talking about global climate, what's happening globally on average. And remember, those are slight changes in temperature that result in big changes of issues. So a rapid increase in the temperature of the troposphere this century would give us little time to deal with the harmful effects. That's one of the things. It's one of the big concerns is if you change the temperature of the globe, there's not a lot of time to react to those issues. And that results in this fear that scientists have. Whether that'll come true or not, we'll have to see. But they have this huge fear of a tipping point. And if you remember, a tipping point is where you get to a stage where you can't reverse the issue. You can't prevent it from getting worse. It will go overboard and then be like a runaway freight train that can't be fixed. And so if you'll hear most scientists be concerned about it from that perspective. And what's it going to do? Well, plant and animal distribution, ocean and atmospheric circulations, all of these things would be altered. And so what if that happens? Well, lots of things would change. This map, this comes out of your book, and you should take a closer look. This is a breakdown of some of the major things that would happen on all the different continents, from glacial changes to sea level changes to agricultural changes and natural occurring flora and fauna changes. So a lot of significant things would happen throughout the world differently in different places. Severe drought would increase. The browning of the earth, if you will. So drought actually accelerates global warming, which leads to more drought. And so droughts actually are a positive feedback loop for global warming as well. So what droughts are: severe lack of water, the growth of plants and trees slows significantly during drought seasons. There's less CO2 that's taken out of the atmosphere during droughts because there's less plants to do that, to absorb it. And more forest fires and stuff occur during droughts, which adds more CO2 to the atmosphere. So all of these are issues with droughts. By the way, groundwater and lake water and river water all gets depleted because of this lack of precipitation, which increases evaporation, which means then we need to do more agricultural irrigation, which creates lots of other problems in and of itself. And so there's a lot of secondary things that come with this global warming business. Ice and snow melting. So global warming happens more, or it's worse, at the polar regions. And this is also positive feedback loop problems. So ice reflects 90% of the sunlight that hits it, and it goes back into space. When you melt that, then now you have water. Water absorbs 90% of the sunlight. So that's a huge shift in the amount of sunlight that's being absorbed versus reflected. And this creates another positive feedback loop we talked about earlier. Increase in temperature melts sea ice. Melting sea ice means more water can be absorbed, more sunlight can be absorbed, which means the temperature warms up, which means there's more melting, which means there's more warming. And so we have another positive feedback loop. And so this picture just kind of illustrates for you some of the shifts that have occurred. This is 1979 versus 2007, and same time in September. show you the changes in the amount of polar ice cap that we've already experienced. In addition to that, the world's sea ice sheets and land-based glaciers are melting. And this loss of ice is happening faster and faster and faster. It's accelerating. It's an exponential problem. And so why should we care about that? Well, there's a couple things. First of all, Arctic ice regulates all the temperature and precipitation here in the United States. So it would alter the climate here in North America quite a bit. We have the jet stream and all of those things and they move up and down throughout the seasons, and they pull air from the Arctic in, and we get precipitation and stuff out of that. And so farming and agriculture, all those things within the United States would change as a result of melting ice. And then mountain glaciers play a really important role in the water cycle, and they produce a lot of available fresh water for lots and lots of people, millions of them, both from drinking and agricultural perspectives. And so if you melt off those glaciers, you alter that water cycle, and that creates some real problems for people who want to drink some water. These pictures actually illustrate or show some shifts in glaciers over the last varying years, 1928 to present, 1948 to present, 1859 to present. And you see that there's far less ice in these shots than there was in the past. In addition, with this meltiness and this hotness, you're going to get sea levels rising. And sea levels have been slowly rising for a long time, but the actually rate is starting to grow. It's starting to become exponential in its nature. So 2/3 of the rise from the thermal expansion of water, and then 1/3 from land ice that's melting and going into the ocean. So a lot of people don't think about that, but sea level rises mainly because the expansion of the water as it heats up, and then a little bit of it is a result of melting ice. And we're not talking about ice in the ocean like icebergs, because they're already buoyant and they're already causing the height of the water to be where it is. This has to be ice that comes off the land or above the water that creates this change in sea levels. So this is one of those things that has a projected irreversible effect, the tipping point factor, if you will. So if you degrade and create a loss of 1/3 of coastal estuaries, wetlands, and coral reefs, if you add all that water in from that temperature, it would destroy all of these ecosystems, which, if you remember, are full of biodiversity. It would change the distribution of coastal fisheries. It would cause flooding in low-lying barrier islands and coastal areas. Agricultural lowlands would be flooded. The freshwater aquifers along those areas underground could be contaminated with salt water. And you, of course, could lose islands in the Pacific and Atlantic Ocean and the Caribbean as a result of it. So these are all things that could be a result of sea levels rising. And so why is that an issue? Well, 13% of the human population, world's urban population, lives near sea level. And so that would alter their life quite a bit. Many cities could be just torn apart by that. Here's a picture of a prediction of sea levels rising only 1 meter in Florida. And the red is all the places that now would be covered with seawater that aren't currently covered with seawater. And you see that that is quite a change in that. And you start looking at the big cities along those coasts and how it alter it. And these are some pictures that would show those changes to and how they would occur with only a 1 meter water change. Next, it would also create permafrost issues. So if you increase the temperature in the Arctic, the permafrost would melt. Now, the permafrost currently has a lot of organic material in it, decomposing material in it that has a lot of methane, and you release that methane into the atmosphere, that would then increase global warming as well. So melting permafrost is also a positive feedback loop when it comes to global warming. And so, nonetheless, that's another problem that would accelerate global warming once more. And then there's this next factor, which is the ocean currents. These are all a map of all the currents that are moving around in the ocean, and they act like huge conveyor belts that move heat all over the planet. Global warming could change these currents. It could, by increasing the temperature of water and adding large amounts of fresh water from melting ice, increasing salinity by increasing evaporation in other places, it would alter these quite a bit. And we don't know exactly how it would or what it would do, but there's a question mark there that is a potentially dangerous one. Because the temperature of the water affects the temperature of the air above it. It affects the climates in certain regions, and so it's going to alter those things, which is a little iffy. In addition, warming up the planet would increase extreme weather situations. So extreme weather is basically a product of temperature shifts and temperature changes. And so tornadoes are an example of that. Hurricanes are an example of that. So a hurricane, for instance, is fed by warm air, warm water in the ocean. The warmer the water, the greater the hurricane potential. And so as a result, you can have much more excessive, stronger storms, more flooding in areas, more prolonged rains in areas, and so creates some real issues there as well. And then as a result of these things, it's a major threat to biodiversity. So you're going to get habitat loss if you're changing climate in certain places, or those ecosystems, of course, are going to change from one type of ecosystem to another. This is going to cause many species to have issues. If you're more of a K species, you face extinction a lot easier. It's specialist species, K species. They don't have the ability to evolve and potentially migrate fast enough to move to a different area where it works. So there's an estimate of up to 30% of land, plants, and animals could become extinct if you only change the temperature by 2 degrees. And remember, it's already changed by 0.74. And then what of those areas are the most susceptible? Well, ones that are near these places where issues could be a case. Coral reefs, right? Coastal wetlands are examples because they're sensitive to water temperatures and water levels. And then polar seas and alpine and Arctic tundra because of the permafrost piece and the temperature needing to be really cold. Those are the ones that have the biggest issues with this situation. And so we've already seen a little bit of that. This is showing you mountain pine beetle kills in British Columbia. If it warms up, the pine beetles can't be killed during the winter, and so they're more likely to live and spread. And this is showing you bleaching processes happening in coral reefs as a result of temperature change. And so both good examples of threats to biodiversity. Now, what else? Well, it will also shift where crops can be grown. This picture shows some of the changes that would occur. The red one is showing where you'd get decreases, and green would be showing where you get increases in growing. Now that increases the likelihood of growing from a moisture point of view and a amount of sunlight point of view, but it does not change the fertility of soil in those places. So now this is a better place to grow from a climate perspective, but from a soil perspective it's not, and so you're going to lose crop productivity in those places. Hopefully that could be offset by having longer growing seasons and genetically engineered crops, but it is an issue nonetheless. And so it will also affect human health. So how is global warming going to affect human health? Well, there'll be more heat stroke. There'll be increased flooding. There'll be more malnutrition and starvation as a result of distribution of food supplies and how that shifts. There'll be a spread of more tropical diseases into temperate regions. You'll have more insects, microbes, toxic molds, and fungi because they thrive in more temperature. You're going to increase the amount of air pollution and more ozone being created with temperature. You're going to decrease the amount of vital natural capital because biodiversity and stuff's being lost. You're going to increase the number of environmental refugees have to move out of one area into another because of drought or whatever the issue is going to be, and that can result in more poverty. So all of these are issues that could stem from changes in climate.